Hey everyone, and welcome back to the channel. If you have been following along, you know we have been diving into Python basics, but today we are taking a massive leap. I'm going to show you how those Python skills can build something truly incredible, a working RISC-V CPU simulator. But the important thing is, and the interesting thing is, I haven't written a single line of this code myself. So I have used Gemini for all the coding. However, I have given all the instructions on what structure of files need to be, how many files need to be, how the design or the code needs to be modular. Then in terms of, I knew a little bit about the Streamlit with the GUI that you're seeing. So a little bit instructions on how to use that effectively and all that. So yeah, we have a version of it. I mean, I have so far some of the and immediate instructions as well as all the R type instruction coded. So I will give you a demo of what I have right now, the version I have. Okay, and a different instruction I will load. I will show you the capability of this GUI right now. I have some of the cool things here as well. So yeah, let's get started into that. So first of all, I want to show you, okay, if you remember, we were working in Google Colab, right? That was very good way because we didn't have to install anything. So it was giving a very good way of checking, testing, and learning the basics of Python, right? And yeah, and then I started coding this RV32i simulator in there, and then you can see the different step. I actually use I don't know how to this pi and g rock how to pronounce it properly, but I use the help of that, and I discovered that through Gemini as well. So I had different cells. I was writing files different, and I was doing some basic stuff. But very soon I realized that this thing, and eventually when I run this, I was getting a link, and I was going there, and I was viewing the simulator. But it was getting pretty slow because I was modifying these things a lot based on, okay, I see something, and then I asked Gemini, okay, update this, update that, and this was becoming super slow. So a major thing that I did was I moved from Google Colab and I installed Python. So I installed not the latest version. I think I installed 3.12.6. That is very important. Don't install the latest 14 version because some of the Streamlit stuff that I'm going to install will create a problem. I had a lot of challenges on that eventually for Streamlit to work. By the way, Streamlit is will give us this nice web interface, graphical interface. Okay, and we will add a lot of more things in it. So Streamlit is useful for that. But again, you don't have to do anything. You just tell the Gemini, I want to create a web application using Streamlit, and I want to have it on my desktop on a computer. Mine is Windows based, as you can see. So you can say, okay, what are the steps I need to do in order to have an RV32i simulator build on using Python? And then it will show you all the steps. So it will ask you to create a virtual environment, but it will give you all the instructions. Okay, and if you encounter problem, what you need to do is take a snapshot of your screen and upload that to Gemini, and it will read those errors and it will give you how to fix those errors. I did all that using Gemini. So I was thinking of creating a documentation for that, but trust me, if get help from Gemini, it will help you on everything, and that's amazing, right? How I can build something like this without hiring any software person on my own in just a couple of nights. And that's the power of AI we are seeing. Yes, it's impacting jobs. Otherwise, I would have hired um, a software engineer. But look at, overall what kind of benefits it's bringing and how it is helping in making this massive progress on the technology side. All right, so with all that chit chat aside, let's get into the demo part. So I have, if you look at this, I have a main app.py. It's gone pretty big now. It started pretty small, which is the core main application that we give to Streamlit. Yeah. And how do I run Streamlit? Do I have here? I moved it up. I think I'm running. One second, give me a second. Do I do it here or not? This where I install it available. Yeah, I learned did that. Oh yeah, I didn't. Sorry, it was right there. So this is how I run it. And when I do this, it gives me a browser. Hey, click on this automatically, and this is where this is. If you can see at the top. So eventually I will deploy this so you guys can, this will be open source. People can use it, update it, further enhance it. But I will deploy it eventually so that you can practice with it. But right now it's just still in the development phase. But yeah, that's what I did, and I get this. And now every time what I do is I have one, two, three, four. These four files, and whenever I ask Gemini to update something, I take the code from Gemini, I just put in these ones, save this, and I refresh this. Right? So it's become a very easy to interact with kind of utility for me, or development platform for me. All right. So let's look into what kind of the capability I have. So as you can see here, maybe lower. So here I have, as I was creating some of the simple things, look at, here you can click on it. And by the way, if you click on this show high register set, this is reference from the book, right? That which is our reference book for the computer architecture. So you can get an idea of what kind of register are there. But if you go back, I, hold on, there's always some problem. when, there's always some problem and you are doing it live. Uh, simulation. But the basic thing that what I'm doing here is you can see here, right? These are all those registers that you see here. So this zero register is here. So whenever if a register has a zero value, then it's will not be green. But if it's non-zero value, it will turn green. You can also see different boundaries in the boundaries in different colors for different registers. So those are different types. For example, you can see all the T's are in this orange uh, boundary, and these some of these, this one is a purple one, all the S1. So I stack them together or group them together, just like this table you can see, so that's easy for us. Okay, and within each register you can see on the left side is the decimal value. On inside the brackets you see hexadecimal. So this is 32-bit register, right? So there should be how many bits? 8. And I should have 8. And this 0x is a notation for that. Now another, yeah, so yeah, you can see all these registers. But another thing I wanted to show you was, I mean, if you don't remember, sometime I forget myself. This basic binary table, when you have 0 to 15, what is the equivalent of it, and what is the binary combination for those? So you can always go back and look there. All right. So let's look into a very simple example. My goal is to code every instruction here. I mean, this is a simulator, right? So what is the idea of simulator? Okay, so a simulator, a CPU simulator, is a piece of software that behaves like a real CPU. It understands machine code, executes instructions, and keeps track of internal state like register. So right now I have only register, but later on I will be adding memory as well. So right now we are just working with different registers. So that's why I'm focusing on immediate as well as R type instruction, and later on I will go into load word, store word, R type of thing. And the goal really here is so we can understand the computer architecture by actually seeing it happening real time, right? But at the same time, I'm going to use this for future system Verilog implementation. So automate that testing. So right now I haven't done that, but I'll figure out how to add some of the features that later on we can give it a system Verilog code, and then it can simulate in a normal way, and then also look at the output of system Verilog code and just compare them. So kind of very autonomous uh, type of verification tool. That's the second advantage of this that I'm intend to use. All right, so let's do the very first instruction. If you remember, what was it? We need to add some initialize the registers. Okay, using add I. So this was like remember some of the variables. So if I do add I, okay, that's the instruction, and I give it, let's say, S1, right? And I want to remember intermediate, you just give it an immediate value. So you say the 2 register and 1 value. Remember the 0 register? 0 register always contain 0. You cannot update. We'll look into it. Let's run simulation. You see here the S1 state after running this instruction has changed. So it was 0 plus 5 and given to S1. And you can see that this is hexadecimal, this is decimal. Cool, isn't it? So now let's add, maybe use, oh, let's use add instead, right? S2 and whatever we have in, okay, that becomes the same. Let's load another one first. Add I. And remember that the immediate was only 12 bits, so the maximum number we can put is really 12 bit. And this is a signed number, so I think it's becomes plus 2047 minus 2048, and this simulator has the capability if you put a number here which is bigger than that, it's going to complain about. Okay, so S2, let's put 0, we put another number 50, and we do add S3 and we put S2, S1. You see that one? We updated S1 as you get 5. S2 we have put 15, and the S3 we have, you know, when we add them is 20, and it has put equivalent of hexadecimal there. So you can really put different instruction there and check the output in different colors. Oh, sorry, in green color. All right. Now, what about when you want to remember in the very first or second video, I said, okay, this is only gives 12 bits, but what about if I want to put a 32-bit number in a register? What's gonna happen without loading it from? So remember there was instruction load upper immediate, right? And let's say is I put in lower one I put 5, in upper I want to do S1, and I want to put and you can also do, by the way, there X, that's easy for me, A, F, C, this will be 20 bits, so 1 2 3 4, one more, 8. Okay, so you can see that the S1, by the way, which is X9. Okay, so lower upper immediate. So upper 20 bits are this. Oh, so this one will put you know, so what we are doing is this is going to do this, and then what we do is it's going to initialize 0. You have seen the right. I think that is the right way. Add I, then what we do is we run put S1, and what do? We put immediate. Okay, so um, output goes into S1, and here I put, let's say, just 5. All right, now you see this. The sequence was not correct. So it put upper significant, the 20 bits, and the low bit is 1. But if you remember that, if you remember my video, I said, okay, if this adds a negative number, right? -5. What happens is when you put negative, it does during addition sign extension. And if that happens, it becomes -1. So this number, the final value actually will be, you can see that final value is A, B, C, D, 7, not 8. So for that, you have to increase this number by another value. Okay. So, but what I did is I created, added an unload immediate. Let's say I want to add, oops, I lost that. Okay. So basically you can do S1, and you can immediate a full 32-bit number. What was the F? Forgot what was it, but anyway, we can put a new number. A, B, C, 2, 3, 8, and you can do 1, 2, 3, 4. So now it's exactly because see, this is not the base RV32I instruction. This is a pseudo instruction, and under the hood, this is where I'm displaying. It executes first load immediate, one incremented like 8, and then it uses, so sorry, it's saying that this load immediate it translates into this and this. Okay, now this one was not a negative number, and this one, let's say, if you can put like some FF something. Let's see this. So now it see it increases it to 9. So, and that's the number it adds. I hope you understand it. This is a corner case that I'm talking about right now, but it was an interesting one. I really wanted to make sure our simulator works for that. Okay, so yeah, so there are so many others, and what I have done right now is I put all of those here. Like, I don't know why this thing is happening, but um, let's see. I thought I fixed this thing yesterday. Um, all right, I need to fix this one. As you can see that there's still some issues. But yeah, I think a lot of things we have. Oh, whatever I load is good. So there is a basic stuff going on there. Anyway, so I think it's a good start. I will start adding more stuff, and as soon as in the next 2 3 days, when I have some more updates for you to share, with you, then I will come and share those. All right, hope you enjoy this demo, and please and give me your comments, feedback. What do you think about it? All right, looking forward to your comments, and I'll see you next time. Bye.